Hi everyone, welcome back to the last practice video or guided practice video of this week. In this problem we're writing a trig function for a graph, so we're working backwards here. We're given a graph and writing a function for it. What I'd suggest again you do is pause the video at this point, work through the problem, see how far you can get, see what questions or what you notice and wonder about working through this problem. Okay, hopefully you paused it there and tried it a little bit. Let's get into it. So the first thing we're going to do is just decide, is this a sine function or is it a cosine function? And the way we go through and do that is we look at where this starts. Since there's no horizontal shift or phase shift to this function, because we haven't covered that or we're not going to this year, we can assume that just identifying the starting point tells us what function it is. As you explored in the first video, you can actually write it as a sine or cosine function by applying a phase shift. But for our sake, we're starting at -3. That -3 clearly is not a maximum, clearly is not a minimum value, so that must be our principal axis. Let's put that in because we're going to use it for future reference. As I finish this, functions which start at the principal axis are always sine functions, so we know this is a sine function. So let's start building a template. This is going to be multiplied by some a, and then we're going to have a b value that we're interested in, and then a x, and then plus c. So these are the three components. We want to find what a, b, and c are, and we just identified that it was a sine function. So let's find a is some value, b is some value, and c is some value. Conveniently, we just found c because we identified it starts at the principal axis. So this function must be translated 3 units down, or -3 is what's being applied as c. From here, let's decide what a is. So the definition of a is it's the amplitude. It's how far above this oscillates, above the principal axis this oscillates. So here's a maximum point, and we can count that distance, or it's how far below the principal axis this oscillates. So there's a minimum value, we can count this distance. In each case, this should be the same, just above or below. 1, 2, 3, 4 units above the principal axis, 1, 2, 3, 4 units below the principal axis. So that tells us our amplitude is 4 and a is 4. Now for the last bit, b, is to identify the period, and we can think back to the initial problem of this week, 1 and 2 actually, where we stated the period. How long it takes to go through one revolution is equal to 2 pi, because we're working in radians, over the b value. So if we want to solve for b, we need to find or locate the period, and we can do that just by following this graph through an oscillation or through one full revolution of the unit circle. So if we start here, we want to go through this function or follow this function until it gets to the same point after achieving a max and a min. So here's the principal axis again. We went past the maximum, so we went 1/4, 1/2 of a revolution. Now we're at 3/4 of a revolution, and now we're at 1 full period or revolution. So our period is equal to pi. So what we can do is substitute that into the equation. So we can say pi is what the period is, and that must be 2 pi divided by our b value. Now some of you can look at this and solve it, but let's keep going. If we want to solve for b, let's get it out of the denominator. That's 1. So we multiply by b here. So we have b pi is 2 pi, and that equals 2 pi. So even clearer now, if we really need to take the factor of pi out, we can as well. So pi over pi make 1, 1, so b must be 2. So our b value is 2, which makes this a period of pi. So we have all three components we're interested in now, so we can put them together and write our equation, and we're set. So the equation of this trig function, graphed below or above where we're about to write this, is y is equal to 4 times sine of 2x minus 3, and if we want to go above and beyond, this would be 4 x values between 0, and it looks like the last written value is 2 pi. So we can put our domain in there as well if we're interested. That would be stopping right here. So that does it for videos this week. Hopefully these 3 were helpful. Look below for the practice of this week where you're going to be doing the same sort of problems. Again, let me know what questions you have. I'm checking Google Classroom constantly. I hope these helped again, and we'll keep in touch.